Contributors in the field of science, 300 BC to 400 BC. Aristotle, 384 BC, 322 BC. Aristotle, one of the most influential philosophers and scientists in history, made groundbreaking contributions across multiple fields, including biology, physics, metaphysics, and logic. He established a systematic approach to scientific inquiry, emphasizing observation and classification. Aristotle's studies in biology involved dissecting animals and meticulously documenting their anatomy and behavior, which laid the foundation for zoology. He also proposed theories on reproduction, growth, and inheritance, highlighting the complexity of life processes. Aristotle's work in physics explored motion, causality, and the elements, influencing medieval and Renaissance scientific thought. He developed formal logic, introducing syllogisms as tools for reasoning, which remain fundamental in philosophy and mathematics today. Aristotle's concept of the four causes, material, formal, efficient, and final, provided a framework for analyzing natural phenomena. His cosmology, based on geocentrism, dominated Western thought for centuries. Aristotle also contributed to ethics, politics, and aesthetics, integrating philosophical ideas with empirical observations. His emphasis on categorizing knowledge influenced the development of scientific taxonomy. Aristotle's observations of the natural world were remarkably detailed, leading to insights about species differentiation and adaptation. His systematic classification of plants and animals revealed an early understanding of ecological relationships. Aristotle's influence extended into psychology, where he explored memory, perception, and consciousness. Despite errors in some theories, his rigorous methodologies shaped future scientific investigations. Aristotle's establishment of the Lyceum as a center for learning fostered intellectual growth for generations. His ability to merge theory with practice exemplified the importance of interdisciplinary studies. Aristotle's teachings profoundly impacted Islamic scholars and European thinkers during the Middle Ages, securing his legacy as a central figure in scientific development. Theophrastus, circa 371 BC, circa 287 BC, Theophrastus, often referred to as the father of botany, made significant contributions to the study of plants and natural science. A student of Aristotle, he succeeded him as the head of the Lyceum and expanded upon his mentor's work. Theophrastus's treatises, Inquiry into Plants and On the Causes of Plants, are among the earliest systematic studies in botany. He classified plants based on their structures, reproductive methods, and ecological preferences, establishing principles still used in modern taxonomy. Theophrastus also explored plant physiology, discussing processes such as growth, germination, and response to environmental factors. His observations extended to medicinal plants, emphasizing their therapeutic properties, which influenced early pharmacology. In addition to botany, Theophrastus contributed to geology, studying minerals and natural phenomena like earthquakes. He proposed theories about the formation of fossils, anticipating later discoveries in paleontology. Theophrastus's methodical approach emphasized empirical observation and practical experimentation, setting a standard for scientific methodology. His inquiries into meteorology and climate patterns further demonstrated his interdisciplinary expertise. Theophrastus's insights into soil composition and agricultural practices underscored his commitment to applying scientific knowledge to practical challenges. His influence spread through Roman and Islamic scholarship, preserving his legacy in natural sciences. Despite gaps in his biographical records, Theophrastus's works reflect a profound curiosity about the natural world. He also investigated sensory perception and the interaction between humans and plants, foreshadowing modern ecological studies. His emphasis on sustainability and resource management revealed an early awareness of environmental conservation. Theophrastus's dedication to observation and classification provided the foundation for future botanical research. His legacy continues to inspire botanists and naturalists in the exploration of plant life. Eudoxus of Cnidus, circa 390 BC, circa 337 BC. Eudoxus of Cnidus, a Greek mathematician and astronomer, is celebrated for his contributions to geometry, astronomy, and mathematical theory. A student of Plato, he developed the method of exhaustion, an early form of integration used to calculate areas and volumes. His work influenced Euclid's Elements and laid the groundwork for calculus. Eudoxus's model of planetary motion based on concentric spheres represented one of the earliest attempts to explain celestial movements mathematically. He also contributed to geography, designing one of the first world maps that incorporated astronomical data. Eudoxus's studies in proportion theory refined mathematical understanding of ratios, enabling precise measurements. His exploration of irrational numbers expanded mathematical frameworks, bridging gaps between arithmetic and geometry. Eudoxus proposed theories on the behavior of light and its interactions with matter, foreshadowing developments in optics. His dedication to empirical observation set a precedent for scientific methodologies in astronomy. Eudoxus's innovations influenced later thinkers, including Ptolemy, whose geocentric model built upon Eudoxus's ideas. Despite limited records of his personal life, his intellectual contributions spanned multiple disciplines, reflecting a holistic approach to science. He emphasized mathematical precision, transforming abstract theories into practical tools for measurement and navigation. Eudoxus's geometric insights were instrumental in the development of trigonometry, aiding studies of angles and curves. His emphasis on symmetry and balance demonstrated the elegance of mathematical principles in understanding the universe. Eudoxus's astronomical observations provided data for constructing calendars and predicting eclipses. His belief in the mathematical order of nature inspired later scientific and philosophical explorations. His teachings integrated science with philosophy, reflecting a unified vision of knowledge. Herophilos, circa 335 BC, circa 280 BC. Herophilos, a Greek physician, is regarded as one of the founders of human anatomy. Working in Alexandria, he conducted dissections to study the internal structures of the human body, a revolutionary practice at the time. Herophilos differentiated between veins and arteries, describing their roles in transporting blood and air. He also identified the brain as the center of intelligence, challenging earlier beliefs that placed cognition in the heart. Herophilos's discoveries in the nervous system included differentiating between motor and sensory nerves, advancing neurological studies. He pioneered research on the pulse, developing methods to measure its rhythm and variations, which became crucial in diagnostics. Herophilos's work in gynecology included studies of the female reproductive system and embryology, providing insights into fetal development. He also examined the liver, pancreas, and digestive organs, contributing to gastroenterology. Herophilos emphasized observation and experimentation, laying the foundation for modern medical practices. Despite the loss of his writings, his work influenced Roman and Islamic medicine, preserving his legacy. Herophilos advocated for ethical practices in medical research, emphasizing the importance of patient care and compassion. His integration of theory and practice demonstrated the value of combining scientific inquiry with practical applications. Herophilos's anatomical research revealed the complexity of human physiology, inspiring future studies. His observations on the nervous system informed treatments for paralysis and neurological disorders. Herophilos's emphasis on empirical evidence challenged speculative approaches to medicine, setting a precedent for clinical research. His contributions underscored the importance of understanding anatomy to improve medical outcomes. Archytas of Tarentum circa 428 BC, circa 347 BC. Archytas, a Greek mathematician, philosopher, and statesman, made remarkable contributions to mathematics, mechanics, and music theory. A contemporary of Plato, he is credited with founding mathematical mechanics and advancing geometric theories. Archytas developed methods for constructing geometric figures and solving equations, influencing the development of algebra. He studied harmonic ratios, applying mathematical principles to musical scales and acoustics. Archytas also designed mechanical devices, including an early flying machine powered by compressed air, showcasing his engineering ingenuity. His studies on motion and mechanics influenced later explorations in physics. Archytas's work in proportion theory advanced mathematical frameworks, aiding the understanding of balance and harmony. As a statesman, he applied mathematical principles to governance, emphasizing logic and order in decision-making. Archytas's exploration of mathematical relationships in nature foreshadowed modern physics and engineering. Despite gaps in historical records, his intellectual legacy bridged abstract mathematics and practical applications. Archytas's contributions to acoustics provided insights into sound waves and resonance, influencing later studies in physics and music. His focus on the relationship between mathematics and nature revealed patterns that shaped scientific thought. Archytas's flying device exemplified early principles of aerodynamics, inspiring future inventors. His theories on proportionality influenced architecture and design, demonstrating mathematics' versatility. Archytas's emphasis on mathematical logic underscored the importance of precision in scientific exploration. His integration of philosophy and mathematics reflected a holistic approach to understanding the universe. Archytas's contributions to theoretical and applied sciences exemplified the potential of interdisciplinary inquiry. Thank you for exploring the remarkable contributions of these brilliant minds who shaped the course of scientific progress. If you enjoyed this content and found it insightful, we kindly request you to like this video and subscribe to our channel for more educational content. Your support helps us continue sharing knowledge and inspiring discoveries. Don't forget to hit the notification bell to stay updated with our latest uploads. Thank you.